core vision of a test that actually teaches. Then we'll pop the hood and see how the digital exam is built, piece by piece. After that, we'll meet the AI brain that gives it all its smarts, check out the super innovative audio tutor, and finally, we'll take a peek into what the future of assessment might look like. Okay, let's start with the big idea. What's the core concept, the driving force behind the Know and Guide numeracy project? The entire project really boils down to this one single powerful question. The goal isn't just to build a platform that grades a student's math skills. No, it's about actively improving them by creating this AI-powered maths pen pal that's right there to guide them along the way. And listen, this is not just some idea on a whiteboard. Version 1.0 is what they call a gold master. That means it's fully built, it's deployed, and it's running stably on Google Cloud Run right now. Every single core feature you see here, from the interface to the AI, is live and working. So, how they actually build this thing? Let's take a look at the blueprint for the digital exam, what the students actually see and interact with. And what's really interesting here is that the team's first goal wasn't to reinvent the wheel. Instead, they made a pixel-perfect copy of an existing national test interface. And the reason for that is actually brilliant. It means students feel comfortable right away. They can focus on the math problems, not on figuring out a new system. It's a smart move, and it's backed by research on what makes these things intuitive. The layout itself is super clean and logical. It's broken into three main areas. You've got the header up top, the main question area in the middle, and the navigation at the bottom. But the really clever part is how it handles the session state. Everything, from the timer counting down to the answers you've selected, is all managed seamlessly in the background. It just works, making the whole experience smooth for the student. Of course, math isn't just about clicking buttons, right? For some of the more complex questions, the platform gives you a whole set of interactive virtual tools. We're talking a draggable ruler for super precise measurements, a semi-transparent protractor for figuring out angles, and even a fully functional scientific calculator. They're all designed to feel and act just like the real thing. Okay, now let's get to the really cool part. Let's dive into the heart of the system, the generative AI that makes this whole platform so smart. So, what is this brain? It's Google's Gemini 2.0 Flash. Now, instead of having a limited
You're on the right track. Remember to isolate to find its value. Try subtracting 6 from both sides of the equation. This will help simplify the expression and bring you closer to solving 4.
It's Google's Gemini 2.0 Flash. Now, instead of having a limited, static bank of questions, this AI model can generate a literally endless supply of curriculum-aligned math problems on the fly. And get this, it doesn't just create the question, it also cooks up realistic wrong answers, what we call distractors, that are specifically designed for a Year 7 or Year 9 level. But of course, there's a catch. Generative AI can be, by its very nature, a little bit random. It's stochastic. And that means every once in a while, it might spit out a question that's just, well, broken. It could be malformed, invalid, or just make no sense. So how do you fix that kind of unpredictability? The solution is just brilliantly simple. They call it robust retry logic. The system demands that the AI's output comes back in a very strict, clean format. If it gets something messy or wrong, it doesn't freak out. It just tells the AI, nope, try again, up to 3 times, until it gets a perfect result. And here's the kicker. This isn't just some quick fix or a Band-Aid. There's research that proves this simple hack of just trying again can make AI performance absolutely skyrocket. I mean, look at this data. For a similar model, the accuracy jumped from a dismal 21% all the way up to a nearly perfect 97%. It's a huge insight. You can get massive gains in AI reliability without adding a ton of complexity. This brings us to what might be the most innovative part of this whole project, a system that helps students without just giving the answer away. This is really where the
Remember the rules for adding integers with different signs. You're on the right track. Consider the number line, starting at 5. What happens when you move 3 units to the left? That's the value of adding -3.
platform stops being an exam and starts being a guide. The way they design the help feature is just so thoughtful. If a student gets stuck, all they have to do is hold down the control key and hover over the question. Instantly, they get a quick nudge, a short audio hint.
But, and this is the cool part, if they keep holding for 5 seconds, the system knows they probably need more help and plays a more detailed strategy. It's a great way to offer help that gets progressively deeper, rewarding persistence.
And to make the whole experience feel a little less robotic and a bit more human, the hints are actually delivered by one of two AI tutor personas. A student might hear from Aura, who has this encouraging, gentle style, or from Robert, who's a bit more structured and logical. And they both have distinct Australian voices, which adds a really nice personal touch. So, where does a platform like this go from here? Let's wrap up by taking a look at the future roadmap. Looking ahead, there are two huge goals on the roadmap. The first is building an analytics dashboard so teachers can get real insights into how their students are doing. The second, well, the second one is a massive leap forward, integrating something called visual reasoning.
So, what on earth is visual reasoning? Think of it as the next evolution of AI, a step towards what some are calling omni-models. This is the ability for an AI to actually understand a student's hand-drawn work on a virtual canvas. It's about understanding the process, not just the final typed answer.
This image just nails the concept. On the right, you see a person effortlessly making sense of a visual puzzle. The mission, the goal, is to get the AI on the
Toggle timer hides or shows the countdown timer to reduce stress. Flag question. Mark this question to remind yourself to check it later. Review grid. See all questions at a glance and jump to any question. Volume control. Adjust the volume of the text-to-speech voice. Toggle timer hides or shows the countdown timer to reduce stress. Play audio. Read the question text aloud using the current persona.
What is the value of?
Calculator. Basic calculator for checking your work. Ruler. Click to open. Drag to move. Use keys or scroll to rotate. Use for measuring lengths in geometry questions.
left to do the exact same thing, to understand a student's drawing, their thought process, with the same intuition as a human. It's a monumental shift from just reading text to truly interpreting creative thought.
All of this really leaves us with one final big thought. If a test can teach you, guide you, and even understand how you're working through a problem, then it's not really just a static assessment anymore, is it? It becomes a dynamic, interactive learning experience. And that forces us to ask, how are we going to redefine the very idea of an exam?
A recipe for fruit punch requires a ratio of 2 parts orange juice to 3 parts pineapple juice to 1 part cranberry juice. If you want to make 3 liters of fruit punch, how many milliliters of pineapple juice do you need? Note, 1 liter equals 1000 milliliters. Think about how the ratio translates into fractions of the total volume. Calculate the total number of parts in the ratio, then determine what fraction of the total volume is represented by the pineapple juice, and finally convert liters to milliliters.